All right, hello everyone. It is Friday. We've just made it through the first week of class, and every week we're going to ask you to come to class on Thursdays and complete a studio activity as you did yesterday. Every week after studio is over on Fridays, I'm going to record and post a studio review video. So in these videos, I'm going to go through the studio from start to finish, show you a solution to the studio as I would do it. If you've completed the studio, it can be useful to see how somebody else may have approached this. It can be useful to review these concepts. Maybe there's another way to solve these problems that you necessarily wouldn't have thought of. So, and if you haven't completed the studio, it can be just a good way to make sure you finish up and understand everything that's going on. So let's go ahead and jump right in. I've got a fresh version of Eclipse Setup here, just like we asked you to install in class this week. And I'm going to go ahead and click on the link. So the first thing we asked you to do is to make a team. I'm going to come down here to the bottom and make a new team for the review. Call it Review 0. Make my team. I'm going to be the only person on this team, but that's all right. Okay. And then we go ahead and refresh this page until we see the link appear here. The next thing that we need to do is click on this green code button and highlight the address that we see in this box. Go ahead and copy that address. And then now we're going to come back over to Eclipse, import a project using Git. We'll go ahead and select the clone URI option. You can see that it's automatically pasted that in to the box for me. And because I've used Eclipse before in the past, it's remembered my GitHub login and my personal access token. We also had to set up one of those on the first day of class. Finally, it's taken a look at the repository. We hit next a few more times here. We don't necessarily need to worry about these things for now. We can just go ahead and click next. We see there's the project, Studio 0, and we are all set. We're all ready to go. I walked through that process just to show you and kind of review that that's how we set up assignments and studios in this class. You're going to get very used to doing that every single time we have an assignment, every single time we have a studio. That's the process that we ask you to go through. But I wanted to do it once on video so that you could refer back to it if you ever get stuck or have any questions about how that process works. The next thing that we're going to do is we're going to expand this project out a little bit. We'll see that inside of this Studio 0 folder, or actually we would call this a package, I see a few files in here. And if we go back to the instructions for the studio, see which one we're see which one we're supposed to start with. It asks us to start with the lunch receipt program. Okay, so let's go find the lunch receipt program. I'm gonna double click it to open it up, and let me go ahead and zoom in on my font here real quick. Sorry about that. Here we go. All right. Sorry for the delay there. I just wanted to blow up the text a little bit so you could see it a little easier on my video. And we have not shown you any code. For a lot of you, this may be the first code that you've seriously taken a look at and tried to understand, or at least one of the first pieces of code that you've tried to look at and understand. There's some things in here that probably look a little bit strange. I would expect there are some words in here that very few people would maybe know or be familiar with what they mean in this context. I see words like static, class. We know what these words mean, in English, but what do they mean in programming? Some of these are going to remain a mystery for a little while, and we'll explain them as we go along. But others, the stuff that's down here is really what we want you to look at, starting basically this block of text that I've got highlighted. This is the body of the program, we would say. And we start by just declaring some variables. You can see that these variables have been named. So whoever wrote this code, it was me, chose the names of these variables and chose them in such a way as to tell a little story here. So I see that the price of a burrito is 7.5, the price of a drink, the price of chips and guac, right? So you can see that we've got some totals for what looks like some food, and then we add all that stuff up. We have a tax rate down here, which looks like we compute the total, and then we print it out. If we actually run this program, right, we can see that our total was $12.76, 75, 62. So okay, seems somewhat reasonable. Right, we've gone ahead and run this program, but do we know that it works? Do we actually know that this program works properly? Do I know that this value is actually correct? Well, I can verify this. I can actually pull out a calculator, or these numbers are not terribly difficult to even try and do a rough calculation in your head, right? So we got 350, 475. We got $12.25 or something like that. So multiplied by some extra tax, seems like this is at least in the right ballpark. It's somewhat reasonable, but we don't need to take somewhat reasonable as the definitive the definitive thing here. We can actually step through this program one line of code at a time and examine things as we go to make sure that every step of arithmetic is actually valid and working the way that we expect it to. So the instructions have you set what is called a breakpoint. So we tell you to set a breakpoint on the first line of the program, line 7. There's two ways you can do this. I actually did this while I was talking just now by double-clicking. So this little circle here shows that there's a breakpoint, right? You can also right-click and toggle the breakpoint that way. Either way, I see a little circle show up here. And now, when I run it, instead of clicking the green triangle to run this, or by right-clicking and running this as a Java program, I'm going to start it in the debugger instead. It's going to ask me if I want to switch perspectives. So if you think about what that means, right? When I'm writing code and running it, that's a different activity from looking inside of my program and trying to figure out what's wrong with it, right? It's the difference between building a car versus trying to look inside of a car and figure out where the belt is broken or something like that, right? So Eclipse provides us two different perspectives to perform these tasks, one for running our code, one for looking at it and trying to find problems, which is called the debugger. So we're going to go ahead and switch over to the debugger now. And you can see that this time when I run the code, it actually stops at line 7. Nothing got printed out down at the bottom like before. The code is paused now at line 7. And over here on the right, I see what's called the variables window. And there's very little here right now, something called args, which I'm just going to ignore for the time being. We may talk about that a little bit later. But the idea is that now I can actually step through this code line by line using the buttons up here at the top. There are two yellow arrows here. I'm going to explain what both of these do, plus this grayed out one over here we'll explain eventually as well. But for now, the only one that you really need to concern yourself with is step over. So if I click step over, you can see that I'm now on line 8 according to what's been highlighted, and I see over in my variables window that Burrito price has now been declared and is 7.5. And if I keep stepping over, you'll see each of these variables as I create them show up in my variables window. So line by line, I am stepping through this program and examining what's happening. Here, when I get to computing the subtotal, I can see this should just be the sum of all of these things, right? Burrito, drink, chips, and guac. That's what I had for lunch. So I go ahead and click step over. There's my subtotal, which gets me to $12.25. I kind of did that in my head earlier, right? Here's my tax rate. All right. Now I'm going to figure out how much tax there is, which comes out to be, it looks like 51 cents plus a little bit left over. And then finally, it prints out, the addition of 51 cents and $12.25 to get us $12.76. That seems reasonable, right? That seems like it's actually working the way that we would expect it to, which is great. It's nice, though, to be able to verify that. And in other cases, right, it may not be true that the program is going to work properly. So in the next couple of examples, we're going to throw a couple of mistakes at you and see if you can use the debugger to fix them. Before I move on, though, just a couple of tips, which is very important to be aware of. If you are running a program in the debugger, this program is actually still running. You can see it's still running. It's actually still waiting. You can always click the red square to stop it. If you debug a lot, so if I click this debugger a bunch of times, you can see that I have a bunch of different versions of this program running over here, and they're all just sitting here waiting for me to continue, right? To continue on. This is taking up resources on my computer. It's like having a bunch of tabs open in your browser or something like that, right? So you can click the red square to get rid of them. You can click the red square to get rid of these, to stop them, right? You'll notice I'm clicking on each one at a time and then clicking on the red square to terminate them. And then eventually they'll all be cleared out, right? And your computer's back to normal. This is also not really where you're supposed to be creating. This is where we're supposed to be fixing problems, right? Finding mistakes. If I'm writing code, which we're certainly going to ask you to do, I would usually use the Java perspective. So we can actually switch back and forth between these two perspectives using these buttons up here in the top right-hand corner. If I want to go back to the Java perspective where I had it before, right? You can see I can click the J button. If I want to go back to the debugger perspective with the variables window over here, I can click on the debug. One other final tip before I move on to the next little exercise that's good to know. Sometimes people's windows will get messed up. So maybe the package explorer disappears. That's a pretty common one. Or maybe the console window down here at the bottom disappears. You can't find any of this stuff down here at the bottom. And so eventually later on, you'll go looking for one of those things. You want to find a different file or something. You're like, my Eclipse is all messed up. Where's the thing? How do I do that? One good trick to know, up in the window menu, if you go to the perspective and then reset perspective, that puts everything back to how it was at the very beginning. So it'll bring all those windows back. You'll notice here's everything down here. The one thing that's actually still missing is my console, which I can get to if you ever need the console by just coming up here to show view and selecting console. That's where the print messages are going to get displayed. So that's a good one to know how to find as well. Okay, now that all of that's out of the way, let's move on to our next program, which is mileage report. So we're going to open up mileage report here, and it just says to run it. So let's go ahead and run this program and click the green circle, and it says the total price spent on gas was $93,000. $93,406.25. And if you look at, how much I drove, it says, car one drove 250 miles, 100 miles, 900 miles. So we did put some miles on here, but like the price per gallon was $3.05. So just some quick math in my head. It looks like I bought, 30,000 gallons of gas for, hundreds of miles worth of driving. Something here does not quite add up, right? There's something here that's just not working out for us. So let's use the debugger. Let's see if we can use the debugger to figure out where the problem is, because I can see that there's more than one place where computation's happening. I see addition, multiplication, things like that. So let's just walk through this step by step and see if we can figure out where in the program things start to deviate from what we would expect them to be. I set a breakpoint right at the top. That's, if you, in these short programs that fit, all on one screen, that's not usually a bad place to put one. It's right up at the top. You can just step through it in a few lines. As your programs get larger and larger, though, I would encourage you to try and be a little bit more specific about where you drop that breakpoint. Try to put it close to where you think the problem might be, so you're not wasting your time stepping through a bunch of code that you think already works. For now, we'll just start it right up at the top. I'm going to click the debug button here. Switch back over to the debug perspective and start stepping through this code. So I see, all right, car 1 miles equals 250, car 2 miles equals 100. That all seems to make sense. Car 3 miles equals 900. I see those show up in the variables window. Total miles, it looks like it should just be the sum of those things together. So if I'm thinking about this in my head, it looks like it should be about 1250. And there it is. I see the 1250 show up. So I'm using the debugger to verify what I expect to be. I now see miles per gallon is 24.5. So if I'm getting 24, roughly 25 miles to the gallon, and I went 1250 miles, what's that math? 25 goes into 100 4 times, and there's 12 of them. So, 48 gallons-ish, right, is what I would expect. 50, somewhere in that ballpark, right? And you'll see, so there's miles per gallon, and then the number of gallons is 30,000, right? Oh, wait a second. that appears to be where we've gone off from our expectations. 30,000 gallons is far too much. So let's look at that last line. How did I get that? It says total miles times miles per gallon. So miles per gallon is 24.5 times 1250. Well, it did exactly what we told it to, right? It multiplied these two values together, but I didn't get the number that I want because actually that's a mistake. That's not a mistake that the computer made. That's a mistake that was made, when this program was written. So this isn't intended to be multiplication, right? It's miles per gallon. So we actually need to do division here to get the number of gallons back out. That's an error. That's a mistake in the code. And as programmers, I would actually argue that being able to find these kinds of mistakes in the code is more important than being able to write correct code, right? You'll notice that there's a reason why I'm starting you out with these kinds of exercises. I want you to get good at thinking about how code works and finding mistakes, because we're human and we're going to make lots of them. So being able to figure out where those mistakes are and get them out of our code is a large part of what programming is. All right. It's not a good idea to change code while the program is running. So it's like trying to fix a car's engine while the car is running, right? Generally not something you want to do. I'm not a mechanic, but I don't think that's how they generally do that, right? So usually you turn the car off before you stick your hand in there. And the same thing is true with our code. I want to turn the code off before I start changing stuff. So even though I'm just making a very small change, I'm going to click the red square here. And you can change it in this perspective, or you can switch back over to the Java perspective and just switch this to be division. If you want to run it through the debugger again, you can, or you can just run it and see if the value that comes out now seems more reasonable. And you'll see that now I got $155. So that's good. That's a lot more like it, right? For 50 gallons of gas, that seems about right. Okay. Let's move on, see what's next. Next, we have the Burrito budget program. All right, let's take a look at this. The Burrito budget program. So, like all of our other programs, we started by creating some things, and by looking at the names of these variables, we're telling a story. We're using the names of these variables to tell a story. So it says burritos eaten week 1 is 7, 4. Burritos eaten week 3 is 19, and then just 1 in the 4th week. Some actual data points recorded by the person who wrote this program, which again was me. I'm not ashamed. So we try to figure out the total number, and then we try to figure out the number of average burritos in a week, it looks like. How much does burritos cost, and the average weekly price. So I'm trying to basically justify my burrito habit by showing, hey, I'm not spending that much money. Like, I'm not spending that much money on burritos, right? Like, I can afford my burrito budget, right? And so it says you have spent an average of $52.50 per week on burritos, which seems kind of high at first glance, right? $52.05 per week on burritos. That's a lot of money, but is it correct? It doesn't seem at first glance to be relatively absurd, but I still think, let's step through this program step by step and make sure that there are no mistakes in here. The computations are behaving the way that we would expect. So if I go through, the first few are going to create these variables. You'll learn a lot more about what it means to create a variable, and then specifically how to do that when you do the prep work this week. But I'm going to step over those as we see them appear in my variables window. I get down to where it computes the total number of burritos. That's a pretty easy one. 11, 20, 31, right? Where'd my button go? There it is. 31 burritos is how many we've eaten, right? So if the average burrito price is $7.50, 31 times, or 30 times 7, would be $210. But we got the 50 cents on there, so we're looking at about 250-ish a week. The average weekly burritos, 31 divided by 4, so that's a little bit less than 32. So it should give us a value close to 8, right? 7 point something, right? 7 point something. So let's see what actually comes back out. I see I only get 7. And so this is a small deviation, but it is still a deviation nonetheless, right? It's one that's not necessarily easy to see, but it could still have, you know, very important ripple effects later on in our program. You can see that when I compute the average weekly price, then based on this value, it is now not accurate because the way that this value was computed is not accurate. But let's try to figure out why, because unlike the last time, I don't see any problems with the arithmetic here, right? To calculate the number of average weekly burritos, it'd be the total number divided by 4, because that's how many weeks there are. So what's the problem here? Well, the problem has to do with the way that information is represented. A lot of people pick up on the fact that I have some values that are declared as ints, and I have others that are declared as double, and it may not be entirely clear what those values represent, right? But when the computer sees them, it appears that, you know, ints are whole numbers, and doubles are allowed to have decimal points at the end. Anytime I'm talking about money, I like to use decimals. Anytime I'm talking about, you know, quantities, whole numbers, I use integers. So if we go back to the line where we suspect the problem is, let's think about what's happening in terms of the data types. The total number of burritos is an integer, right? I can see it's declared as an integer, and that makes sense, right? They're all whole numbers. The number 4 is also an integer, and so the computer looks at this and says an integer divided by an integer, regardless of what the value is, right? It doesn't matter to me what the actual number is, but the type is going to be an integer. So even though the value comes out to be 7 point something something something, the computer says, well, this needs to be an integer, and in order to make that happen, it simply chops everything after the decimal point off. Just chops it off. Another question that I get is, well, this is declared as a double. So, you know, why is it still storing 7? Doesn't this tell the computer that we actually wanted to keep all the decimal information? And the answer is yes, that's true, but it happens a little bit too late. It's going to compute this arithmetic first and then take that result and try to put it into this variable. So you can see that when it stores the 7, it doesn't store it as number 7 like it does up here for an integer. It stores it as 7.0, indicating that, yes, it is a double, but the integer arithmetic happened just before that. This is a common thing that we see with computers, right? So how would we fix this? How could we possibly fix this problem? There's a few different ways, right? If an integer divided by an integer gives us an integer, well, let's see if we can get a double in there somehow. So I can change total burritos to be a double. That would work. Or I could change this to be a double by putting a 0.0 on the end, actually. That's also a way that we can inject a double into this. And now, integer divided by a double has to be a double, right, in order to retain all of the information involved. If we run the program again, after making, oops, and so here I made a mistake. I was actually changing that code while it was still running, which is what I told you not to do. But, you know, I'm human, I make mistakes. So here we go. This is what will happen if you see that. And the right thing to do here would be to probably click the terminate button and close all running copies, right? That's a reminder. Oops, I need to stop everything. So close all running copies and then go back and start it over again. See what happens. All right. Now we see you've spent an average of $58.12 per week on burritos. The number changed. It went up, which is, you know, maybe not necessarily what I was hoping it would do for my burrito budget. But based on the arithmetic that we saw, this is more accurate, right? This is a more accurate value. And you know, this is a very obvious, trivial example. But you can think that we use computers to do all kinds of useful things. And having a mistake like that in a computer program that's, you know, actually computing the cost of burritos or, you know, a cash register, for example, or even more importantly, like running an MRI machine or flying a plane, those kinds of mistakes could have disastrous outcomes. So as programmers, that's one of our responsibilities, is not just to write good code, but also to go back, review the code that exists, and keep improving it, making it better. All right, The last example as part of this studio I'm actually not going to do, and in large part because unfortunately the way that things are set up, I could probably rig up a way to do this by myself, but it would be, I think, not necessarily even particularly useful for me to show that to you because of all the hoops that I would have to jump through. You really need, more than one person to do this effectively. So I really hope that you got a chance to do this exercise in class, to send messages back and forth using Git, using your Git repository, but just to kind of review how that process works, because this is also how you submit your homework assignments. So it's important that you especially know how to commit and push your work. When you commit and push something, you can equate that in your brain as, making it available to me and the TAs to see your work and grade your work and access your work. Until you commit and push something, it is only visible by you on your computer. But when you commit and push it, it actually sends it up to GitHub, and because I have set everything up on GitHub, I will then have access to it. I can see it. So to show you how that works, right, you'll see that my original repository, which you can always get back to by clicking the link. So if you ever want to get back to the repository, you can always go back and click the link that you used to create the repository, and it'll always take you back to where you were. So here you can see is the original code as it was given to me. But I made a bunch of changes. Well, not a bunch. I made a few small changes in my code specifically to fix a couple of problems. How do I make sure that those changes make it back? So I'm going to go ahead and commit and push my work by right-clicking. And so where you right-click, I actually would encourage you to just right-click on what's called the project. So if you're working on a studio, right-click on the studio, the folder for that studio. If you're working on an assignment, right-click on the folder for that assignment. Go down to Team, and then click Commit. This window will pop up. Sometimes it's scrunched down here at the bottom, so you can come down here and drag it up if you need to make sure you can see everything. These are the files that have been changed. So if I look at these files, these are the ones that I've changed or modified. The ones that I want to commit and push, that I want to send up to GitHub, I'm going to drag them down here to the bottom. And they're supposed to show up down here in the bottom box. I have seen this issue before where they don't, which is a little bit unfortunate. If you run into this problem where you're dragging and they don't show up, the best solution that I have found is to restart Eclipse. So I'm going to restart Eclipse briefly. In fact, if you run into problems with Eclipse, restarting Eclipse is, in general, just a good thing to try. It won't always work, but it does fix a lot of random little problems that can pop up. Okay, and now we can see that I've restarted Eclipse. It's registered the fact that I was trying to commit and push these, so they show up down here in the staged changes. So everything that's down here in staged changes, that's what's going to be sent. All right, and in particular, I'm changing the files that I know I've made changes to. If you want to put everything down here, though, that's not necessarily a bad thing. I now need to put a message over here in the box. I'll usually say something like Studio 0 is finished, or something along those lines. I'm then going to click the commit and push button, which will save those and ship them up to GitHub. You can see that it says it's been a success. If I close this box and then go to the GitHub page for my repository, I can refresh this and see that, all right, now, right, it gets those changes immediately. Studio 0 is finished. That's the message that I just wrote. So now I can see it, right? If you can see your code online on GitHub, that means that I also will be able to see it. For this class, I'll also be able to see it. Okay? So that's how committing and pushing works. There is also a way that you can, communicate with other people who are using your repository. So particularly for studio exercises, it may be useful for you to also pull, which means if somebody else has committed and pushed some work, you can pull that work to your computer, right? And we had you do that as part of Studio 0. I'm not going to be able to show that now as I explained, but that is a useful technique to know. Not as useful on the assignments because they are meant to be completed individually, but can be useful on the studios. And just, as a general programming technique is extremely, extremely useful, something that I do just about every single day. So that wraps up the review for Studio Zero. Just to kind of real quick wrap up this review video, I just want to take a brief moment to remind you of what's coming up next week. The way that this class works, after you have a studio, you're given an assignment. And so the assignment that you're asked to complete this week is Assignment 0. But as I mentioned in class, both Studio 0 and Assignment 0 do not count for credit. They're just practice, right? So go ahead and take a look at Assignment 0. It has you, moving a little robot around the screen. Have some fun with it. I think we ask you to draw a house down at the end. You can be as elaborate and detailed or crude as you would like. It doesn't really matter to me. But in order to submit work in this class, as you found out yesterday in studio, you need to show your work to a TA. So on assignments, we're actually going to be, a bit more detailed about what it means to show us your work. In particular, if I click on the page for Assignment 0 on Canvas, if I open that up here, down at the bottom of this page and down at the bottom of every assignment page is a rubric. So when you sign up to demo your work, the TAs will walk through this rubric with you and check off each thing. So be sure to do this before you come to class. Go through all of these things ahead of time. Make sure that you've got everything that you need and that you're prepared for any questions the TA might ask you when you submit your assignment. So you can do that in class. You can also do that in office hours. Our TA office hours have not started yet. They will be starting just before Assignment 1 is due, which is our first assignment for credit. And so, Assignment 1 is due on the 31st. Our TA office hours are scheduled to begin on the 29th. My office hours, actually, you can schedule an appointment with me right now if you'd like to. I'll show you that in just a moment. But before I do that, one final calendar note. Please note that on Tuesday, you've got two options. So if you want to go turn in Assignment 0, again, not for credit, you don't have to, but if you want to go get practice with the demo stuff, you can go to the computer labs in Herb Hour to do that during your regularly scheduled time. Alternatively, I'm going to be doing a prep work review. So before you come to class next Thursday for Studio 1, we're asking you to do some pre-studio prep, which means that we're asking you to read this entire chapter from the textbook. I know it looks like a lot of stuff, but it's actually, it should take you an hour or two, hopefully. I realize some people may take longer or shorter than others, but that's the intention, is for it to take you a reasonable amount of time to go through these exercises and read the contents of the prep work. If you can do that on your own, then fantastic. You're ready to show up to studio on Thursday. But if you would like for, to come ask some questions or see me go through some of the exercises in the prep work, then I will be running prep work review sessions. I'll be doing it on Tuesdays in McDonald 162. So, and that'll be during your regular time slot. So, if you normally have class at 11:30 on Tuesdays, I will be in McDonald 162 on Tuesdays to do a review session. If you normally have class at 1 o'clock or 2:30, you can attend McDonald 162 at those times if you want to go through the prep work with me. And I will record and post those just like I record and post these studio reviews. The last thing that I want to note before I sign off today is that I have opened up my office hours. So if you go to Canvas for this class and you click on the office hours link here on the left-hand side, my office hours are all by appointment. So I have a lot of students in this class. It's important to try and be as available to as many people as possible. And in the past with open office hours, I find that I just get swamped and feel like I'm not giving anybody the appropriate attention that they deserve. So instead, I've decided to switch to an appointment-based model. You can sign up by clicking this link online whenever you want. I've got my calendar all set up. You can see there's times available for the next few weeks. I keep this schedule up to date, so if you see a time on here, it should be good. I should be available. There's lots of time slots. So they're only 15-minute time slots, which I know does not sound like a lot of time, but I think you would be surprised at how much ground I can cover in that amount of time. If you truly feel as though you need longer than 15 minutes, you're always welcome to email me and set up a longer appointment if you'd like to. But you can use this for anything. You can, come ask questions about materials. You can come demo an assignment. I can go through prep work with you. Whatever you would like. I'm available to meet either in person in my office or via Zoom, and I really want you to come. So, I need to go change this message though, don't I? I'll go change that right now. But anyway, this is now open. This is now available, and hopefully I will see you in my office sometime soon. I would really love to see as many of you in my office as possible this semester. All right, that's gonna do it for this studio review. I hope you enjoyed your first studio experience and have fun with the assignment. I will see you in class next week.